Okay, so now let's talk about how may we analyze the previous first order condition and what are the insights that we may get. So in the previous video we have derived this particular equation. Okay, this is how the retailer's first order derivative is with the order quantity qt star. We want to see whether this particular quantity can be zero or not. So before we really try to solve it, we may first see some special cases. The first one is the most generous return contract. That means you are allowed to return everything unsold, and for each unit unsold, I pay you back what you have paid to me. Okay, R is W and the R is 1. In this case, the only situation that this particular quantity is 0 is when C is 0. Or we can say as long as there is a positive production cost, then the order quantity is not going to be efficient if the contract is so generous. To prove it is very simple. If we plug in R to be W and the capital R to be 1, this particular equation can be reduced to blah 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 blah, this one. Okay? And because we know P is greater than W, the only possibility is for C to be 0 so that this equation can be 0. Okay? So this proposition is true for every possible demand function. Okay, and then it tells us that if we are allowing 4 returns with 4 with 4 credits, then in general it is system suboptimal. Okay, if we are too generous, if we are so generous like this, what will you do as a retailer? You will order as much as possible, and the order quantity will be larger than qt star. Another situation is just the wholesale price contract. Now we also can prove it that with the wholesale price contract, it is impossible for the system to be efficient. Okay? So again, if R is 0, then we plug in R to be 0 somewhere there. And then we can see that this equation requires W to be C, which cannot be true. Okay? If capital R is 0, then again we can get something that is very similar. Again, it is impossible. So as long as R is 0 or capital R is 0, then the system cannot be optimal. When this happens, there is no risk sharing at all, and the order quantity must be smaller than qt star. So allowing no return is also system suboptimal. So now let's consider 4 returns with partial credits. Suppose capital R is 1. Then we can show that for the system to be efficient, we need this equation, or we need W and R to be set according to this equation. So let's look at this first. Suppose R is 1, then the second term will be, the last term will be cancelled. Okay? And then if we need the first part to be 0, that's exactly what we need here. Okay, so that's one thing. Then we want to ask whether this is possible. For any P and C, R and W such that this constraint is satisfied can also be found to satisfy this system optimality equation. So basically that just means you may find R and W to satisfy this equation. Okay, so according to this equation, if we do some arithmetics, what we really need is, given each wholesale price, set the return credit according to this formula. And then because W is less than P, we can show that this particular ratio is less than W. You just need to do some arithmetics. And also because C is less than W, we can see that this is non-negative, or I should say it is positive. So that means as long as your W is less than P and greater than C, your R, according to this formula, will be greater than 0 and less than W, which is reasonable. Okay, so we just need to allow 4 returns, and then as long as we set up the partial credit according to this formula, then it will be system optimal. Okay, and then we say the return contract coordinates the system. So this result is significant. We have shown that as long as we allow 4 returns with partial credits, then it is possible to find system optimal coordinating return contracts. And to remind you, W is the wholesale price, R is the return credit, and here we can see W is just a linear function of R. Okay, so that means when R is small, W should be small. When R is large, then W is large. Okay, reasonable. And also we can see if R is 0, W is just C. So that means if your wholesale price is just your production cost, then to achieve system efficiency, your return credit should be 0. On the other hand, if your R is W, or if you are so generous about return credits, if your R is W, then we can show that you can still find a contract to coordinate this system. Okay, so these are something you may expect. Interestingly, you can see that from the system's perspective, all the pairs of W and R that satisfy this equation are the same, because the system together earns the maximum amount of money. But we also care about whether both players benefit from the maximized total profit. Okay? Because previously, under wholesale price contract, each of them are earning some amount of money. If under return contracts, the system profit is the system profit is a lot, but one of them are earning fewer amount of money, then that return contract cannot be implemented. So we need to ensure win-win. Okay, and then we are hoping that the system profit can be split to the 2 players in any way we like, or arbitrarily. Okay, so that's what we want. We know we are able to make the pie the maximized. Okay, we know we can get the efficient pie, and then we ask whether this pie can be split arbitrarily or not. So to answer this question, let's first look at 2 limiting cases. Suppose W is C, that means I as a wholesaler, I set the wholesale price to be my cost. As we mentioned, then R should be 0. In this case, as a manufacturer, I earn nothing. Okay, when I sell, I earn nothing. Though I don't need to pay any return credits. And if I get nothing, that means the retailer gets everything. And then, in another limiting case, if my wholesale price is so large, if my wholesale price is P, okay, then I need to guarantee the retailer for all the unsold unit. In this case, I as a manufacturer, I earn everything, and the retailer is just my slave for getting my product and sell them. Okay, when I sell the product, the retailer gets nothing, and I just guarantee the retailer that it will not lose any money. Okay, so in this special case, the manufacturer earns everything. How about the intermediate case? Let's discuss it. So the set of coordinating 4 return contracts can be depicted like this. So let me do this. I know I have W and I have R. Okay, these two parameters are something that I should decide when I am designing a return contract. W should be between C and P. Okay, and R should be between 0 and P. In the previous slide, we have the equation, and you may verify that when W is C, your return credit should be 0. When W is P, your return credit should also be P. And because that function is linear, so it will just be this one. Okay, if you choose W and R so that you are the WR pair locates on this particular line segment, then the system profit will be maximized. Also, we have observed the following. If W is C, then that means the retailer is earning everything. Okay, at this particular point. Or if the wholesale price is P, then the manufacturer is earning everything. Okay, so that means we may draw another graph like this. So let's say this is W. Okay, W is from C to P. So there is one level which is just pi t star. What I want to draw are the manufacturers and retailers' profit as a function of the coordinating wholesale price. When W is C, the manufacturer is getting nothing. Okay? But when W is P, the manufacturer is getting everything. And what's more important is that because this particular function is continuous, so our function must gradually go up from 0 to pi t star. Okay, so that means it must be something like this. So for example, this one. Okay, it may be of another shape. It may even go up and down, but at the beginning it is at 0, and at the end it must go up to pi t star. So this blue line is pi m star. Okay, and then I'm going to draw another curve to depict the retailer's profit. It must be pi t star subtract pi m star. Okay, so it will look like this. Oh, it's not very pretty, but you know what I mean. Pi m star and pi t star, pi m star and pi r star, sum of them must be pi t star. Okay, so the sum of the two curves must be exactly pi t star. And the black one is just the retailer's profit. So if this is the case, then we know arbitrary profit splitting can be achieved. Okay, given any level of profit you want, you know where there is a W that can help you to get that allocation. Okay, no matter what's the amount of money you want to give to the manufacturer, there is a wholesale price that can do that. For example, if you want the manufacturer to get this amount, then you just need to find, oh, there is a wholesale price that can achieve this. And then you are allowed to really split the pie according to this setting. So now we have confirmed that return contracts are really amazing. Okay, it can help the system to earn the maximum possible amount of money, and it can definitely make everybody happy because everyone can earn more than previously earned. So we are about to give you a conclusion. We now know that return contracts can be coordinating. It can induce the retailer to order the efficient inventory level. and then make the channel efficient. Also, it can be win-win. And this is very important because this is how the supply chain players are willing to participate in a return contract. So as a manufacturer, if I am smart enough, I can design a return contract that can induce the retailer to accept. Okay, because I am able to make the retailer happy to accept the return contract because the retailer is able to earn more while I am also earning more. So this is a very important property for the contract to be really implementable. The two players will agree to adapt a coordinating return contract because of this win-win property. And also the consumer can also benefit from channel coordination. Why? Basically, the consumers only care about one thing, which is the inventory level. Okay, because the retail price has been fixed. So the consumer just want the channel can offer as much quantity as possible. The consumers prefer a higher quantity. So under the coordinating contract, the quantity, the inventory level is QT star, and we know it is greater than Q star under the wholesale price contract. Okay, so that just means if the two players choose to coordinate with the return contract, then consumers also benefit from it. Finally, I want to tell you, coordinating is good, but not all the coordinating contracts are win-win. Sometimes a coordinating contract cannot make everyone happy. One of the players is going to get everything. In that case, the coordinating contract may not be implementable. And also, you probably want to think about this. In practice, some manufacturers are saying to the retailers that I'm going to sell you some product. If you cannot sell all of them, I'm going to compensate you, but you don't need to ship the physical goods back to me. Okay? The manufacturer does not want those unsold finished goods, but the manufacturer will still pay the retailer even though those items are not shipped back to the manufacturer. I think you are able to find the reason behind this. Okay? It's just about incentives. The manufacturer wants to buy back those products, not because the manufacturers want those salvage value. It's because the manufacturer wants to provide incentives for the retailers to earn more. Okay? Everything is about incentives. So, in this paper, this paper discussed about the return contract. We only introduced the main idea of this paper. There are still a lot of things that we did not touch in this paper. For example, this paper showed you that salvage values and shortage costs can also be incorporated in the model. Nothing will really change. The paper have shown that the manufacturers and the retailers' expected profit are monotone or monotonely increasing and decreasing when W goes up. Okay? Previously we draw this figure, right? Well, this is C, this is P, this is wholesale price, manufacturer's profit, and the retailer's profit like this. Intuitively, this is true, and the paper can show you that this is really true. The manufacturer's profit goes up. Maybe non-linear, but it always goes up with W, and the retailer's profit goes down. Finally, the paper even showed that if there are multiple retailers, the manufacturer can still, or when it is impossible, for the manufacturer to coordinate everything here. Okay? So it's very interesting to see what's going to happen if there are multiple retailers. And if you want, read the paper by yourself. Okay? In general, this opens the field of supply chain coordination or channel coordination about how different formats of contract may or may not coordinate a supply chain. It was really a hot topic about 30 years ago, and every topic will be dead eventually. So now it is not so hot. But I just want to give you this idea about coordination because this is one of the very good examples about mechanism design. Okay? Through the change of contract format, we are changing the gaming rule and we are changing the equilibrium behaviors of players. And then we may achieve a better results. There are other contracts that may coordinate a channel or a supply chain. To name a few: two-part tariffs, quantity flexible, revenue sharing, sales rebate, blah 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 and blah. They are just a lot. In the lectures, we will discuss some of them to give you more ideas about how to give incentives, how to align incentives in a supply chain with different kinds of contracts. Thank you.